New edition of the Heat Treat podcast. Today we have a good friend of mine, one of the best salesmen on the heat treat industry, one of the most charismatic and experts on the subject, Mr. Josh Harvey. How's it going, Josh?
How are you? Good to see you, bud.
Good to see you, bro, and super excited to talk to you about cost savings on the heat treat industry. We before the podcast, Josh and I talked about what are the main wastes and areas of opportunities on shops, on commercial shops, on captive shops. He's been around for some time visiting shops. He represents a quite variety of very big companies regarding the fixture, the heat treat industry. But why don't you tell us yourself a little bit about your background, who Josh Harvey is, how long have you been on the business, how many companies have you visited, how many companies do you represent? I mean, you're like a legend in your area, Josh. So
What?
can you start doing that, please, and introduce yourself to the audience?
Yeah, if you're going to say that, I'm going to have to start this interview like I'm going to
Oh,
be Ed.
that's
I'm going
Ed
to be
Ball.
Ed from now.
We should actually ask Ed to be on the podcast.
Ed Ball.
I didn't thought of that. That'll be fantastic.
My daughter found that the other day. I had to explain what it was, but that was the great Ed Ball that's retired. But yeah, 22, 21, 22 years, I guess I've been in this, and still learning. Everything is evolving, but I enjoy it. I've been in the Southeast here for, all that time, covering all the Southeast states, I guess you'd say. And been working with Kyle for, I guess, 17 years now. So when I came on board with him, he had a lot of companies he rep for. So between 8 and 9 companies. So we sell for everything from capital equipment to alloy to, belts and control systems, software. So pretty diverse, amount of things that we touch on. So, but I try to think of myself as like a problem solver. That's really my job. So, and I've always taken the approach of increasing service life and uptime of customers' equipment. So that's kind of what I do. Selling, in my view, it kind of comes along with that. You're either going to sell something to fix a problem, or it's a process where they fix it themselves. But at the end of the day, hopefully you make friends and good colleagues and customers.
And I believe one of the biggest added values of having a salesman like you in a shop is like you visit many companies, captive shops, commercial shops with many applications different from each other, right? And you have a bunch of experience, right? Because some customers, they might have problems, a certain problem, and you are able to tell the guys, hey, I know how this can work in a certain way because other applications, right? Visiting many customers, many companies, and you have tried, I believe many solutions for certain problems, but you know which to attack, right? So what can you tell us about that? Being on the road, because I know that you spend a lot of windshield time visiting your customers, and they're very different from each other, different applications, different markets. But at the very last, they're all doing heat treat. So that has given you a very broad vision regarding the applications from each company to from each other.
Yeah, everybody has some NDAs and confidentialities, and learn some trade secrets from people, but you don't, you try to share what's relevant and not share what you can't. But a lot of people, commercial heat treaters, they tend to know across the board. They seem to always know what the other guys are doing and have their own answers, and it's very interesting to see that when your product is heat treat and that's what you're shipping out the door, you seem to know a lot more about heat treat. A captive shop, their product may be gears, but and heat treat is not the focus of the plan. You usually can tell that by the amount of funding they get, for example, or you know, the priority in capital. But essentially, I have seen a lot of different types of industries and shops, and that's what really I love about this. One of the things you get to see some neat parts, some neat factories, some really cool people that from Navy submarine background to pilots, to Marines, you just meet a lot of different cool people, PhDs. But again, some observations I'll try to help you with that I've seen out there.
So thanks for sharing that. So now let's get into the technical stuff that we all love. We're talking about heat treat today. So typical wastes or areas of opportunities when heat treaters, no matter if they're captive or commercial, can actually save cost. Everybody's talking about cost saving right now, especially now that the demand is down on automotive. Everything, there's not many projects to expand. I mean, everybody's playing defense right now. How can I save money? Produce lower volume, but also decrease my bills.
Right.
You and I talked a little bit before the podcast regarding, of course, maintenance is always a big issue, a big cost for a heat treat. So we got their insulation and alloy, what we would like to call internals, radiant tubes, rails, you name it. Fixturing, right? It's also a very, very big cost. Fixtures and trace of fixtures of heat treat, and as well energetics, right? If you don't have your burners tuned, if you're wasting too much energy, that's also a big, very big expense, and also labor. But there's so much you can do there, right? But let's try to focus on the furnace itself, on the process. So what comes to your mind when they say, a customer asks you, I need to play defense and save a little money, reduce my costs?
One of the first things I think, and probably one of the easiest, is just to tune burners. I know there's a lot of them out there that don't keep their settings long, but I mean, that's one area where you can basically get more BTUs out of using less gas and higher output or throughput of the furnace. You get closer to stoichiometric, 2% excess air, for example. I mean, you're putting more heat into the parts, you're getting them out faster or reaching set point faster. Gas is relatively cheap. I don't expect it to stay that way, but that and electricity, I expect to increase and be a bigger cost line item for any manufacturing. But that's one of the big ones. I would say, running equipment to failure, Carlos, if you don't pick a PM date, your furnace usually will pick one for you, and it's never a good time. And you just want to try to get that scheduled to shut it down, especially if you observe or your people observe, critical issues like, let's say, even heating elements, the resistance is jacked up and it's showing that maybe some elements may go down, or you got a wall fall out in your bricking. You want to schedule that, go in there and take care of as much as you can. As far as the tubes, you want to maybe consider changing those if you're, I don't know, rattling on. But as far as alloy goes, for example, I think everything can be solved with material changes. So, and I've kind of proven that, allowed customers to prove that for themselves. So if you've got a part inside your furnace that the real cost is going in to get it, and the real cost is not running your furnace, to pay a 10 to 25% premium on a higher grade material to get you from that 1 year PM cycle to 2 years, for example, that's worth it. And there's a lot of low hanging fruit out there for that to happen. You had mentioned like Super 22H to me. That's always been one that's a material I've always recommended for carburizing and, 1800 Fahrenheit approximately.
I would like to make a stop there just to clarify this, because this can be a tricky subject to the audience that doesn't know, or don't have a technical expertise on alloy, right? But I mean, there's the standard type of alloy that mostly everybody uses, which is HT, which is like a standard grade alloy, right? And we will say that will last about a year, right, under correct operations, right? That's like a rule of thumb. But if you don't have your burners tuned, right, your atmosphere at the right set point, I mean, you're gonna still damage those burners. I mean, those radiant tubes, right?
Yeah.
So, will upgrading alloy to a higher grade will be a solution for everybody, or just for the guys that do carburizing?
For everybody. I mean, only the people that, like I said, if you've got a component that is not making it and everything else is making it, let's say to a nice point, 2 years out, 1 year out, 3 years out, that particular item needs to be looked at closely for improvement, and like I said, sometimes it's just tweaking the material. Heating elements, I've done this a lot of times, like a bayonet heater goes out every, we got to replace those every 9 months. Well, first it's the tube, that gets a hole, and then the element sees the atmosphere, and then it shorts out, or the inside of the tube dusts, and it creates a pile of dust that comes up and shorts out the element. So you got to look at everything. But if you've got a heater that is not performing over time, you might have a watt density issue. The guys at Custom, I've worked with them for years on that. Reducing the watt density reduces the localized heat within the heating element, and you can spread that out to reduce that, because at some point the actual element itself will go molten in the center. So you want to try to keep that temperature down. So it might mean also going from like a 70-30 nickel chrome to a 80-20 for a higher temperature application. Or, there's some real exotic alloys that go up to 3000 C, I mean, moly disilicide and other things that you can use. But in a nutshell, on your average heat treat shop, carburizing is very destructive for tubes. Some of the microalloy alloys like Super 22H, like I said, handles that very well. It's very strong, keeps its shape. If you've got rolls and you get a lot of TIR run out, they're warping, that'll solve that. And you might just need that in the soak zone where it's the hottest, not in the charge end,
So let's think about, for instance, a pusher furnace. So we had a pusher furnace, right? And we know that zone 1 is the one that is getting peaks of temperature because you're opening and closing the door. Would you recommend to have kind of like super alloy on zone 1, and the remaining, which is going to be a steady process variable like temperature or carbon potential, to reduce the alloy? So you just invest your money on where is it worth it instead of investing in the whole 4 zones. Would that be that accurate to say?
I look at big furnaces like belts or pushers. It's kind of like 3 furnaces in one. You got the door opening and closing is almost like spraying water on everything. So you got to be ductile there, So even with insulation, you want to utilize something that's as ductile as possible. So, using an HT or an HU, for example, a skid rail in the first zone where the door's opening all the time, that's probably the best choice. It'll probably get you a better life there than, say, something stronger, built for higher temperature, but becomes brittle over time when you quench it. with the door opening. So it's kind of a, if you just think logically about what's going on in that area and then look at, all right, these things are failing here, these are failing there, and it doesn't always add up. But the goal again is to get the whole unit to a PM schedule that is acceptable to you. I see people always striving for a 2-year PM. Some are at a year, some are at a year and a half, and the goal is 2, right? So that's where you shut it down cold. But
Yes, I assume, in my point of view, a 2-year PM, that's a long time. If you're running mass production, I mean,
there's some out there.
There's some out there, and I don't blame them, right? But 2 years can be very tricky, right? I will heavily recommend a 6 months checkup, a 6-month checkup, 1 year PM, and have a record and try to switch components every other year or so. But 2 years in order to shut down the furnace and open it, it's going to be relatively very expensive, right? That's my opinion.
Yeah, and I'm not saying there's people that blast on through. I mean, you're going to have a weekend down and fix a fan or put in a sparger or you name it. But that should be the goal, I guess, is continually extending that. Whatever it is, it depends on what you're doing, but extending your PM schedule.
So you mentioned something that actually I never heard, but it's the term, but everybody does it. He's running equipment to failure, right? In your experience, how many percentage of the heat treats you have relationship with, they will run the equipment to failure without doing a PM? Because I believe this is a very common mistake, because they want to save money by not investing on spare parts or service. But when the furnace breaks down, it's maybe twice as expensive as servicing it on time.
Yeah. Not to offend any accountants, but when they override engineering and maintenance, sometimes you see issues where, decisions are made that tail wags the dog, I think. So, at some point, like I said, it's going to pick its day as shutting down. So they have a facilities maintenance group or engineering has to be given the ability and the tools to attack these issues, when they need to be. And, everybody will have a different opinion of what to do. Do we change out a belt every time we shut down, or do we, try to get by again? Do we change out all the tubes or the ones that are back? But, when accounting starts weighing in and wagging that tail, it tends to create issues where they're left with no alternatives. But, let's say production, always say production kind of runs a plant. They tend to be the top decision maker. When production wants, results, then it has to be done. And, sometimes to an extent that can be calls for equipment to just not make it. So I don't know if I answered the question.
Yes, I mean, this is the common denominator I see, is whether if they have business and they have to process parts in order to build them, right? And the furnace needs some maintenance, they prefer like, okay, let's just keep building more stuff. Let's just ching machine, right? And let's worry afterwards if the furnace collapses, right? So this is basically what I see. I believe they will have more troubles not sending production out that if the furnace was to break down later, right? Because that's how I see it, right? So in a way you did. Now I would like to go in another subject, which I know that you have deep expertise on, history, right?
Yeah.
So it's commonly known that there's two types of fixtures, right? There's rod frame baskets and cast fixtures, right? It can be a fixture basket, or if you're running a high volume part, you cast a fixture in order to optimize production, right? What can you tell us about what's the best way to save money by using rod frame baskets, cast baskets? There are even some companies that are doing hybrid baskets that I haven't used. Or if you're running high volume or a single part to use cast fixturing, and to which grade, right? HU, HT, or some maybe they put some niobium on it sometimes. But when do we have to use rod frame baskets versus cast baskets, or when do you have to go and say, I need a cast specific fixture for this part number?
Well, okay, rod frame, I tend to agree with using those because of just the ease of use, the versatility of those, the cost. Cast fixtures tend to lend themselves to a repetitive process, something you're doing over and over. A commercial shop rarely gets those. And when they do, you do see them investing in those for specific parts to get, more pieces in a load. One thing you might not notice about a cast basket, that, it does reduce the perimeter. You basically get more out to the edge of the tray. Rods kind of take up a little bit of that as a perimeter, but as a whole, cast baskets, they do cost a good bit. They have, they will become somewhat brittle over time. A casting does have higher strength. They're all austenitic alloys, like 330 and HU, and so they don't change. They're not going through a hardening process or heat treat process. They don't respond to heat treat, so they tend to stay strong. But really, a casting has a little bit higher carbon when it's cast, so that does give it a little bit more creep strength. But the ductility of a rod frame basket, that's been welded with pressure welding. It's very strong, long lasting, and versatile. I think a 5/8 rod frame basket is probably one of the most, as you can see by any shop, you'll see them around there, either 5/8 or 1/2 inch. 5/8 is the best bang for your buck, though. 5/8 330. For vacuum, you might see Inconel 600, 601. I think Inconel 600 is the best for the money. The 601 is a little bit higher alloy, but it's got a premium. The mills that make this, they're pretty proud of it, I have to say sometimes. And there's some new ones out there. I always pick on HR 120, which is Haynes. If Haynes people are watching, please just make more of what you're doing there, because it's a good material, but it's pretty much cost prohibitive. But yeah, to answer the question, if you have a product that you're running all the time, you might want to invest in a pattern, which will cost $5 to $8 grand or so, for a fixture that will hold your part properly, allow it to be quenched in the right orientation. But you're not going to be using it for a lot of different kinds of parts. It's going to be pretty specific. So you're going to invest a lot of money for that one thing. So commercial shop, you either want a cast or a rod basket. Yeah.
And also that you quote and sell a lot of these fixtures or spare parts, but we have the history-wise, there's been by nickel, there's an increase in pricing or a decrease in pricing. How does the market behave on this? Because also you get a scrap value out of this, right? What's like the common practice when nickel is up, prices go down, prices go up, and later it kind of drops, but you kind of you see like spikes on the market. what would be your recommendations for users to purchase alloy with these spikes on pricing?
Carlos, you've probably seen, I think you pay some of the bills around there. You've probably seen it's pretty expensive right now. Nickel's at a 5-year high. Scrap is too. And when you go to buy new, it is as well. But when the nickel price goes down, there, of course, is a little lag. You're not going to see it reflected in your, cast or wrought alloy. And that comes straight from, either a small foundry, a big foundry, a giant mill making 330 rod. It just doesn't follow right along with that curve. But anyway, right now we are at a high. Cobalt's at a high for the higher grade alloys, but selling scrap, that's always a good return on investment if you do it right. I guess, you want to bid it out to make sure you're getting the best price per pound. A lot of big companies want to, or let's say a maintenance department within a company want to retain that as part of their as a credit rather, so that they can purchase more, apply it back into that maintenance budget. Otherwise, it's kind of a loss for their line items there. But at the end of the day, getting a good return on your scrap is important. But yeah, nickel is the driver of the cost of everything. So I don't know, like I wanted to mention, like on fixturing in the past, well, I still notice like Japanese based corporations, they tend to always use a lower grade or lower nickel fixture, cast usually, for a repetitive part. Just seems like it's always been that way. And their competitors, American competitors, will use a higher grade, like let's say a HW for something that's quenched. They both will tell you that that works for them. That's the best way to do it. So I'm talking HH, which is probably 18% nickel, to the guy that buys the HW, which is 60%. So, the guy that's selling the scrap with 60% nickel gets that return. And I guess it really comes down to how often do you like to buy alloy and bring it in and unwrap it and put it on the line, because one guy's doing that a lot more, but they both will tell you it's the best cost effective way to do it. So
it is what it is, right? But it's everything. Yeah. So on a nutshell, everything is driven by nickel, and we do not have control or can speculate of how that's going to behave, right?
Yeah.
So my advice to the viewers will be just keep track of the nickel pricing, right? Because you have weapons when you know that it's going down. You can actually call your alloy supplier and say, hey, I got this quote from last month and I see that there's a drop. So just don't place the order with with that price.
Yeah.
That'll be my recommendation. I mean, that happens.
Yeah, I mean, keep an eye on the graphs, just like you keep an eye on maybe energy prices, electricity, yes. But it ends up being a cost, right? So, but again, like I said, fixtures, they go in the furnace, they come out again after a certain period of time. Rolls, roller reels, fans, chain guides, those things go in and you don't want them to go back out because it requires a guy and 2 days to cool down. So those are the things I like to focus on, increasing the life more, because there's a huge cost associated with that, in my view.
So let's switch to another topic of how can we save cost, which is atmospheric generation.
Yeah.
Right. I know that you also are very good on this subject, right? So let's talk about endo generators, right?
Mhm.
Technology has advanced a lot, and there's systems out there that can actually help you to reduce gas consumption to what you're using for. So what can you tell us about cost savings on gas, especially, well, you mentioned, we already talked about burners, right? That will save you
Mhm.
some, but on atmosphere generation, for, let's say, for companies that have belts or pushers or a bunch of IQ furnaces, what would be your advice to them? We already talked about burners, maintenance, fixturing. Now let's go into atmosphere, which is also a big part of the question because you're running it constantly, day by day, furnace by furnace, and sometimes uninterrupted for 10 years, maybe some
Yeah,
companies. Yeah, so that's a lot of energy and energetics that is constantly used, that if you save, let's say, 20% of it, that's a win. That's a home run.
yeah. Hey, I always say the endo generator, if you know, got several furnaces running, depending on that, it's the most important thing in your heat treat shop. And you need to have spares for everything on that generator because it's a showstopper. Maybe you got a backup generator, which is the best way to look at it. In fact, probably makes sense to have it hot and ready to switch the valve to send gas downstream to everything. Otherwise, everything you got in all your furnaces is subject to decarb and rework. So have a backup generator. Your dew point control system needs to, you know, companies that we know, Carlos, they do a good job on manufacturing these. They're out there. They'll automatically switch the um, air to gas ratio to keep your dew point right dead nuts, right on what you want it to be all the time. And that can change winter, summer to morning to night even. And um, doing maintenance on generators, you know, some people will burn out on a calendar date. You know, that's never a good idea because it probably doesn't need it half the time. Um, if you have a 3-gas analyzer, that's your best tool for a lot of preventive stuff. So if you see your CH 4.06, you want to burn it out. That means you're not cracking the gas. So it means your catalyst is sooted, you know. So you want to do it based on that. And again, check your dew points at your carbon potentials at the furnace. But endo generators always have a retort around. You know, when you do these burnouts, there's systems and manufacturers that basically you can hit a program, kind of like you do a recipe, and it'll do the burnout, which is drop it to approximately 1600 degrees. And then it'll watch the rise of the temperature because you'll get a higher temperature there. And that's kind of eating up your, you know, your retort. So you don't want it to get out of control. So, you know, probably want a human being to keep an eye on that. But, you know, the temperature will rise as that carbon is burned. So, you know, most heat treaters understand all this, but I still see them out there. They'll burn out on the weekend just because it's the weekend, but it's killing your retort and your catalyst, you know. But yeah, generators, you got to have the spares. You got to make sure the gas is cooling. The cooler has to be operating, or the gas will reverse in the tubes and become soot all the way down through the furnace and out into the interior. So
Generators can be a showstopper if you don't take care of them, and that can be very costly if you have a bunch of production and you don't have a generator up running, a retort, catalyst, or maybe you got a bad dew point and you have a bad generator. So that is like the most, I would say, the most critical part of a heat treat is the generator, right?
yeah,
Josh, it's been
yeah,
fantastic talking to you about cost savings, common wastes. We talk about burner, we talk about alloy fixturing, maintenance, a lot of people that run equipment until failure, right? alloy upgrades to higher alloys, special alloys, how you want to call it, that's up to everybody. And also the increase of life, right? So
Yep.
thanks for sharing that with the audience. But before we close the show, you've been 20 something years in the industry. You have met a bunch of people. You have visited many facilities. You have sold a bunch of equipment, a bunch of retrofits, a bunch of maintenance, a bunch of things, and deal with a lot of people, purchasers, users, managers, CEOs, you name it, right? And your way around the industry of heat treat. But as I'm telling everybody on the show, we are losing more people like Ed. If you want to grab that mask again, this guy Ed Ball that we're gonna have on the podcast was one of the most senior guys on heat treat. A life of heat treat, a lot of experience, a lot of companies visited, many applications, battery methanol, generators, pushers, belts, you name it, right? Vacuum, carburizing, nitriding. But we're losing a lot of knowledge, a lot of technicians, well-known metallurgists. They're retiring, and we're not filling that gap with the new generations. We're seeing a lot of turnover with the new engineers. They don't want to get their hands dirty. Heat treat might be not as sexy as some of the other jobs out there. But what would be an advice that or an experience that you would like to share with the new guys that are entering the industry that you would like to have been told when you were younger, that you learned through your career?
Yeah, listen to elder people that you're working with, or you probably had the honor of working with your dad, who had extensive heat treat. I guess my heat treat dad was probably Bruce Favors, and then Kyle along with him, who's an expert in his own right. But Bruce, when I worked with him, he had 40 years experience, in heat treat. So people like that are invaluable in your life. If you're in a facility that doesn't really have much to lean on. I mean, you had Tom Morrison on, and I can't remember if he mentioned his classes, the Mpi Classes. They've got a subject, they've got a class for every subject you can think of, maintenance to metallurgy,
safety,
safety,
right,
NFPA.
leadership, right?
Get your company to sign you up for those and do the online, and you even get a certificate. I tell people that all the time. That's a great resource, and it's just sitting there online. So, I would tell younger people to, take a leadership role and take what you're doing as serious, and, have a leader mindset, I guess. You might be the only guy that really cares about that particular area of the plant. They need, what was it, Cindy and them called it a champion. Be that guy. You're in an industry that's very small. It's a niche. If you get good at it, people will become interested in knowing what you have to say, and you'll rise up. Carlos, at some point a few years ago, I realized, I looked around and I was like, people my age are making big decisions and are big corporate positions, late 40s, mid 40s, and kind of strange when you see, people that are peers of you that, are being looked to for answers. So be that person. Don't be afraid to be that person, that'd be my advice. Learn and then get cocky about it. But you know what I mean.
I do. Josh, thank you so much for sharing. I had a blast talking to you. I do learn a lot from this podcast as well. And thanks for sharing this. I believe it's very valuable, since you visit a bunch of companies with different applications, and you and I have met. We met like 20 years ago, and I have found. We've done successful business together. We have done. Basic shows together, and you're always in the industry very well connected. Thank you so much, Josh.
Yeah, thank you, man. Same to you, bud.
And I would like us to remind our audience that we're uploading a weekly podcast with power players of the industry like Mr. Josh Harvey, the sales shark of the Southeast of America. And we're uploading this podcast on YouTube, LinkedIn, and Spotify. You don't have the video capability. So we'll see you next week on the Heat Treat podcast.